Welcome to the third video lecture for week 2 of the MPP math class. This lecture will focus on interval notation for sets and also on solving problems involving inequalities. Interval notation, you've probably seen it before. The thing to realize is just that we use parentheses to denote that we are not including the endpoints in the set. So in this case, the value of x is between a and b, but does not include either the value of a or b. If we want to include the value, which is a greater than or less than or equal to symbol, we would use square brackets. You can also include one endpoint but not the other by using a square bracket for the included endpoint and a parentheses for the excluded endpoint. If you have an interval that extends all the way out to infinity, in other words, you have just a is less than x or a is less than or equal to x, you can just include the infinity as negative or positive infinity in the interval notation. When we do algebra with inequalities, most of the standard algebraic manipulation works the way that it does in any other form of algebra. However, first, you can't just flip the two sides of the equation. You have to also flip the direction of the inequality. We don't see people having too many problems doing that consistently correctly. The place where people get tripped up a little bit is making sure that if you are dividing by a negative number, or multiplying by a negative number, you absolutely have to flip the sign of the inequality. So just to do an example here, if we have negative 5x plus 10 is less than negative 8, we subtract 10 from both sides, and then we divide both sides by negative 5, and notice that the direction of the inequality also flips. We can graph the solution here on the real number line. Notice that x is greater than 18/5 but does not include 18/5, and we indicate that on the line by using an open circle. That circle would be filled in if this were x greater than or equal to 18/5. The place where these problems get more complex is where you have a variable in the denominator. So you can't just multiply both sides by 2x minus 1 because you don't know whether 2x minus 1 is greater than or less than 0. So instead what we do is we treat it as a fraction. We move the 7 to the other side. We multiply the 7 by 1 in the form of 2x minus 1 over 2x minus 1. We can then do fraction addition or subtraction. We get in the numerator 3 minus 14x plus 7, all quantity over 2x minus 1. And now we know that that quantity is less than 0. So in order to make it less than 0, we need either the numerator to be negative and the denominator to be positive, or vice versa. What this does for us is it again creates several cases. We're going to once again check at what point is the numerator greater than 0 versus less than 0, at what point is the denominator greater than 0 versus less than 0. So in this case, we see that the denominator flips sign at 1/2, and the numerator flips sign at 5/7. And so in order to make this negative, we need either x to be less than 1/2 or x to be greater than 5/7. As before, we can graph that on the number line. Notice that x is greater than or equal to 5/7. The x is less than 1/2 because we can't divide by 0, so we need to exclude the x equals 1/2 solution from the solution because it's not a valid value. So in this example, we have two terms that are multiplied together that are greater than or equal to 0 together. In order to make this true, we need either both terms to be positive, both terms to be negative, or either one of them is allowed to be 0. So in order to make both of them positive, we need simultaneously 3 minus x to be greater than 0 and 2 plus x to be greater than 0. If we solve that, we get that that is true on the interval between -2 and 3. In order for both to be negative, we solve the exact same set of problems, just pointing with the signs in the opposite direction. But here our solutions are that x has to simultaneously be greater than 3 and less than -2. The intersection of those two sets is the null set. That 0 with a slash line through it is the set notation for a null set. And so there is no value of x for which that is the case. So in this case, we have that single interval from -2 to +3, including the endpoints in the graph. To do one final example, we have here an absolute value example. And so now we need to consider the two cases for the absolute value. The first where 5 plus 3x is positive, and the second where 5 plus 3x is negative, and the absolute value is reversing the negative sign. So we solve it for the two cases, and we get the solution that x must be greater than -4/3 or less than -2, which we graph on the number line using the open circle to exclude the endpoints. This is probably a good time for you to do a little bit of practice on your own, solving these for x. Pause the video and start again when you're ready. So take a moment, check your values, check your work, check the graphs, and once you're done, we've reached the end of the video lecture.